Hi everyone, it's a pleasure to present the poster and introduce our work, Surface Kinematics and the Yang-Mills Integrants at String Conference. I'm Jin from the Institute of Theoretical Physics in Chinese Academy of Sciences, and I'm also currently visiting Uppsala University. This poster is based on these two papers, especially the second one with amazing collaborators, Nima, Chu, Carolina, and Song. You can also find more details in Song's talk. So our work is based on a recent reformulation of the scattering amplitudes. We define and construct the canonical loop integrand for the Yang-Mills. This integrand is very interesting for the following properties. It solves the ambiguities with tuples and massless external bubbles. It also satisfies the perfect gauge invariance and loop cuts. And finally, it vanishes at infinity in some directions, allowing us to compute it recursively. To begin with, let me introduce the so-called surface integral. To define this integral, we need to specify a surface and the triangulations. We will focus on the one-loop cases, so the surface will be a disk with two unmarked points and a puncture inside. The triangulation, for our purpose, need to be the so-called scaffolding triangulations, which means we need to have this smaller n-gon, while the details in size is not important. Given these informations, this integral is then determined, and the output of the integral is the loop integrand for different theories. And the results are functions of the kinematic variable x associated with curves on the surface. And there are two things I would like to mention. We have included the closed curve, delta, which encodes the information of the space-time dimension. And these x are assigned with momenta by homology, while the red and blue one here are assigned with the same momenta by homology. But we need to keep it differently. This is crucial for the feature that I mentioned in the beginning. Now for our purpose, I will directly jump into taking the deformation parameter alpha prime delta to be 1 and take the scaffolding residue as well as the low energy limit. And this defines our desired loop integrand for the Yang-Mills. Now, let me explain the three important features very quickly. For tuple and massless bubbles, we do have kinematic variables that corresponds to their propagator. So these things appear quite naturally as regulator in our language. And as I mentioned, our integrands satisfy gauge invariance and the loop cut. For example, the loop cuts are given by the following form, which involves derivative on the three amplitudes. And crucially, these are exact statements, which means we are not off by any scaleless terms or any shift of the loop momentum. Finally, the integrand vanishes at infinity under this shift, which means we can compute it recursively. And the simplest example at one loop 1 point is given by this. Thank you for your attention.